Hey everyone, and welcome. Today, we're going to be decoding a secret language, one that's hidden all around us in the world of chemistry. And once you get the hang of it, you'll start to see the hidden structure of, well, pretty much everything. So, have you ever looked at a chemical formula and your brain just kind of goes fuzzy? All those letters and numbers. It can look super intimidating. But I've got good news for you. It's not just random gobbledygook, it's actually a code. And today, we're going to crack it together. Okay, let's just dive right in with this guy. Mg3PO42. What on earth does that even mean? It looks like a real monster, I know. But stick with me, because by the end of this, you'll be able to look at this and know exactly what it is, no problem. All right, so to crack this code, we have to meet the key players. These are the secret agents that really make these formulas tick. I like to call them the atom teams. Now, the official fancy science name is a polyatomic ion. And all that means is it's a group of atoms that are bonded together so tightly, they basically act like one single thing with one single charge. But honestly, there's a much easier way to think about it. Let's just call them atom teams, or if you like, molecular squads. The big idea here is that they're a package deal. They move together, they react together, they're always on the same team. They never split up. Here are some of the most common atom teams you're going to run into. See that one? Phosphate? Its formula is PO4 3-. That just means it's a team made of one phosphorus atom and 4 oxygen atoms, all huddled together acting as a single unit that has a 3- charge. It's a team. Simple as that. So, we've met the teams. Now what? How do we actually use them to build stuff? Well, that brings us to the assembly rules, the playbook for writing these chemical formulas. Don't worry, it's just 4 simple steps. First, you write down the symbols. Second, you add their charges. Third, we do this little trick called the criss-cross. And fourth, you just write out the final cleaned up formula. Let's just do one together. It'll make perfect sense. Okay, let's build the formula for a compound made from sodium and our carbonate team. Step 1 is super easy. Just write their symbols. So we've got Na for sodium and CO3 for our carbonate team. And seriously, trust me on this. Always put the team in brackets right away. It'll save you a lot of headaches later. Step 2, let's add their charges, which you can just look up on a chart. These charges tell us their electrical vibe. So sodium has a 1+ charge, and the entire carbonate team, as one unit, has a 2- charge. The whole goal of this game is to make those opposite charges balance out to 0. And now for my favorite part, the criss-cross. It's such a neat little shortcut to balance the charges. You take the number from the charge of each part, forget the plus or minus sign for a second, and you make it the little number, the subscript, for the other part. So carbonate's 2 crisscrosses down to sodium, and sodium's 1 crisscrosses down to carbonate. See? And finally, step 4 is just to write it out all nice and clean. So we get Na2CO3 1. But, in chemistry, we don't bother writing the number 1 as a subscript. It's just implied. So we can drop it, leaving us with our beautiful final formula, Na2CO3. That's it. Okay, hold on. Pause for a second. This is the single most important rule you will learn today. Are you listening? You must never, ever, ever change the numbers inside the brackets. That little 3 in CO3, that's part of the carbonate team's identity. It's what makes it carbonate. If you change it, it's not the same team anymore. So just don't touch it. Phew. Okay, so now you can write the formulas. And I've got even better news. If you can do that, reading the names is way, way easier. So let's flip it around and learn how to read the names of the things we just built. The rules for naming these compounds are awesome because they're so simple. There are only 2 steps. You ready? First, you say the name of the metal. Second, you say the name of the polyatomic ion. That's it. I'm not kidding. That's the whole thing. And here is the absolute best part. Unlike some other naming rules in chemistry, you do not change the ending of the atom team's name. If its name is carbonate, you call it carbonate. No "-ide" endings, no tricks, no nothing. You just say its name. Let's try it with CaCO3. Okay, rule 1, name the metal. Calcium is calcium. Easy enough. Rule 2, name the polyatomic ion. CO3 is our friend, the carbonate team. So now you just smush those 2 names together. The final name for calcium carbonate is calcium carbonate. It really is that simple. You just say what you see. And just like that, you did it. You totally cracked the code. That thing that looked like a scary, mysterious chemical language just a few minutes ago, well, now you know it's just a set of clear, predictable rules, and you know how to use them. So let's do a super quick recap of the 4 big takeaways. Number 1, polyatomic ions are just atom teams that always stick together. 2, use that handy crisscross rule to write your formulas. 3, the golden rule, never change the numbers inside the brackets. And 4, naming them is easy. Just say the metal's name, then the team's name. Hey, remember that crazy formula from the beginning? Mg3PO42? You can look at that now and know it's magnesium phosphate. And more importantly, you know why it's written that way. So I'll just leave you with this question. Now that you can read this part of chemistry's secret language, what are you going to discover?